Hello and welcome to Chapter 7, The Human Memory. I would imagine that each of you will pay particular attention to this chapter because there will be hints and strategies that will help you improve your memory, which is certainly very helpful in your daily lives. The textbook, the content online, this particular lesson all culminates together to give you a very good summary of how psychology looks at the human memory. Memory is much more than taking in information and putting it in some kind of mental compartment. We have to get it back out too. Many psychologists study factors that help or hinder memory storage and retrieval, thus attempting to answer three basic questions. How does information get into memory? How is information maintained in memory? And how is information pulled back out of memory? Encoding involves forming a memory code or putting information into memory. Storage involves maintaining coded information in our memory over time, and retrieval involves recovering information from our memory storage. So let's look at encoding. The first step is getting information into memory is to pay attention to it. Attention involves focusing our awareness on a narrow range of stimuli and events. Selective attention is a term used by many psychologists to describe this paying attention to something process. However, the word selective is really redundant. Attention is selection of input. Usually, attention is likened to a filter in an information processing model of memory. The filter screens out most stimuli while allowing a select few to get by. So in terms of this filtering, much of the research that's been done has been done to determine whether this filtering process occurs early in the information processing sequence or later on. And it appears that both may be at play here, so that sometimes you're paying attention to someone talking with you at a party and suddenly you hear your name from across the room, and so your attention can be drawn to multiple locations or multiple points. Early selection models propose that input is filtered before meaning is processed, like late selection models that hold that filtering occurs after the process of meaning. This is evidence to support early, late, and intermediate selection, suggesting that the location of our attention filter may not be fixed. So we have a filter that can be used in a variety of capacities. According to Craig and Lockhart, whether or not we will be able to remember something depends on how deeply we process this information. So figure 7.2 illustrates the different levels of processing. So let's take a look at figure 7.2. So attention is critical to the encoding of memories, and as we've learned from our content and text, not all attention is created equal. You can attend to things in different ways, focusing on different aspects of stimulus input, and according to some theorists, differences in how people attend to information are the main factors influencing how much they remember. So Craig and Lockhart in 72, both from the University of Toronto, and proposed an important model in this area. In their formation, they argue that the different rates of forgetting occur because some methods of encoding create more durable memory codes than others. So they propose that incoming information can be processed at different levels, and so for instance, they maintain that in dealing with verbal information, people engage in three progressively deeper levels of processing, and that's structural, phonemic, and semantic encoding. And so we look here that structural encoding is relatively shallow processing that emphasizes the physical structure of the stimulus. So for example, if words are flashed on a screen, structural encoding registers such matters as how they were printed, capital letters, lowercase, and so on. Or the length of the words, how many letters were there. Further analysis may result in phonemic encoding, which emphasizes what a word sounds like. So in phonemic encoding, involving naming or saying, perhaps silently, the word. So finally, a semantic encoding emphasizes the meaning of verbal input and involves thinking about the objects and actions of the words and what they represent. And these levels of processing theory propose that deeper levels of processing result in longer lasting memory codes. So you can see here in figure 7.3 that retention at 3 levels of processing involves progressively deeper levels of processing, and this led to progressively better retention. As you look here at the graph, structural encoding led to a retention that was about 18 words recognized, and a semantic encoding led to about 80 words that were recognized in percentages. So this is significant in terms of depth of processing. What about enriching encoding? Elaboration is a process by which stimulus is linked to other information at a time of encoding. So for example, if you're studying phobias for your psychology test, you can apply this information to your own fear of spiders. You're making the association of your own fear of something and you're connecting it to the concept of phobia. So as you know, if you have a fear of spiders and you're learning about phobias, you know how you feel when you have a fear of, when you see a spider, you know what that does for you in your body, you know how that makes you have a higher or faster heart rate, how you end up feeling a little adrenaline rush, you feel a little anxiety, you understand what that anxiety feels like. So you can make those connections, and then you can write about a phobia based on connecting it to your own fear of spiders. Elaboration often consists of thinking of examples. So self-generated examples seem to work best, the ones that you come up with yourself that are meaningful for you. Again, for example, if for me, if I was learning about fear and anxiety, I might connect that to an example of how I feel when I see a mouse. Mice make me fearful and cause me anxiety, so that connection allows me to have a more meaningful elaboration that helps and works for me. Visual memory involves the creation of visual images that represent the words to be remembered. So you complete concrete words are much easier to create images. So for example, a juggler and truth, the connection of justice and truth. Dual coding holds that memory is enhanced by forming semantic or visual codes, since they can lead to a stronger recall, which we learned in some of the research we talked about previously. Self-referent encoding involves deciding how or whether information is personally relevant for you, and that is that information that is personally meaningful for you is more memorable. So historically, for example, Plato and Aristotle compared memory to like a block of wax that differed in size and hardness for individuals, or various individuals. So memory was like stamping an impression into the wax that you held. Today, with our advances in understanding the brain and technological advances, the analogies have become more sophisticated than this. In 1968, for example, Atkinson and Schifrin proposed the analogy between information storage by computers and the way information is stored in the human memory. And this was what we call the information processing approach, where we have basically drives of memory into 3 different stores in our brain. We have sensory memory, short-term memory, and long-term memory, and this is depicted in the following figures. So Atkinson and Schifrin proposed that memory is divided up into information stores. So sensory memory can hold a large amount of information just long enough, a fraction of a second, for a small portion of it to be selected into a longer storage. Short-term memory has a limited capacity, and unless aided by rehearsals, its storage duration is brief. Long-term memory can be stored more apparently unlimited amount of information for intermediate periods. So you can see how we shift from sensory memory, we pay attention to it, we rehearse it, it becomes short-term memory, and then we store and retrieve from our long-term and short-term memories. Sensory memory is basically information preserved in its original sensory form for a very brief time. And this type of memory allows the sensation to linger briefly. And if we go back to the idea of sensation and perception, you think about those concepts of the visual system or the auditory system or the sensory olfactory system. And then the visual and auditory sensory stores appear to decay in about a quarter of a second. And so, and George Sperling in 1960, a classic experiment in terms of visual sensory store, he illustrated how brief the sensory store actually is, and his experiment is depicted here. Sensory memory allows the sensation of a visual pattern, sound, or touch to linger for a brief moment after the sensory stimulation is over. So in the case of vision, people really perceive an afterimage rather than actual stimulus. You can demonstrate this by the existence of afterimages for yourself by rapidly moving a lighted sparkler or flashlight in circles in the dark. If you move a sparkler fast enough, you should see a complete circle even though the light source is only a single point. The sensory memory preserves the sensory image long enough for you to perceive a continuous circle rather than the separate points of light. And this brief preservation of sensation in sensory memory gives you additional time to try to recognize the stimulus. However, you better take advantage of the sensory storage immediately because it doesn't last long, and this was demonstrated in the classical experiment by George Sperling, and his subject saw 3 rows of letters flashed on a screen for just 1/20th of a second. A tone following the exposure signaled which row of letters the subject should report to the experimenter, and subjects were fairly accurate when the signal occurred immediately. However, their accuracy steadily declined as the delay of the tone increased for 1 second. And why? Because the memory trace in the visual sensory store decays in about a quarter of a second, and memory traces in the auditory sensory store also appear to last less than a second. So, while very brief, the sensory memories are clearly important, affecting, among other things, the richness of our visual perception and the accuracy of our construal of our world and the decisions we make. So figure point 7.6 really demonstrates that point. So short-term memory is really defined as a limited capacity to store that can maintain unrehearsed information for about 20 seconds. George Miller in 1956 wrote a famous paper called The Magical Number 7, and plus or minus 2, and some limits to our capacity for processing information, where he illustrated that the average person could hold between 5 or 9 chunks of information in our short-term memory. Recent research is building consensus that we have overestimated our short-term memory capacity due to unaccounted for subject chunking. So a chunk of information is a group of familiar stimuli stored as a single unit. So for example, the following number, look at 8675309, can be thought as 7 individual numbers, or they can be chunked together in groups of 2 or 3. So for example, 8675309 or 8675309. Our short-term memory also has a limited duration, so in other words, information can only be kept there for a brief period of time, and then it's lost unless rehearsal occurs. So rehearsal is the process of repetitively verbalizing or thinking about information and keeping it in use. So for example, the number 8675309, I would rehearse that and say 8675309, 8675309. Think about it in my head, maybe chunk it or not, but that rehearsal in keeping it in use allows me to then process it. Peterson in 1959 concluded a study illustrating how quickly information is lost in our short-term memory, and this study is illustrated in the next slide. So let's look at the next slide. In Peterson and Peterson's 1959 study of short-term memory, after a warning light was flashed, the participants were given 3 consonants to remember. The researchers prevented rehearsal by giving the subject a 3-digit number at the same time and telling them to count backward by 3 from that number until given the signal to recall the letters. By varying the amount of time between stimulus presentation and recall, Peterson were able to measure how quickly information is lost from short-term memory. So let's look at short-term memory as we've evolved from a number of problems in the original model of short-term memory. Short-term memory is not limited to phonic encoding or phonemic encoding as originally thought, and decay is not the only process responsible for loss of information. These and other findings indicate that short-term memory might be a much more complex aspect of memory than when originally thought. Alan Baddeley proposed a more complex model of short-term memory that characterizes short-term memory as working memory with 4 specific components. The phonological rehearsal loop represents all of the short-term memory in the original model. This component is active when it uses recitation and temporary hold on to information. The visuospatial sketchpad allows temporary holding and manipulation of visual images. So, for example, when you are in your mind rearranging furniture in your bedroom and you can see that happening and you're holding on to those concepts in your visual memory. The executive control system handles the limited amount of information that's juggled at one time as people engage in reasoning and decision making. So, for example, when you're at work and you're weighing the pros and cons of something. The episodic buffer is a temporary limited capacity store that allows the various components of your working memory to integrate information, and that serves as an interface between working memory and working and long-term memory. Working memory capacity is referring to one's ability to hold and manipulate information with conscious attention. And it's believed that it to be stable, heritable, and it contributes to intelligence, and it contributes to music ability, creativity, and other behaviors. So think about it like this. If you are a musician and you are playing an instrument, but you are also reading music, and you are also singing and looking at words, and you are also anticipating changes in notes, and you can do all those things at the same time and do them very well, then that is really what we're talking about in terms of working memory capacity and being able to connect that to music ability or intelligence, decision making, and other behaviors. In figure 7.8, in terms of looking at short-term memory as working memory, this diagram depicts the revised model of short-term store proposed by Alan Baddeley. And according to this researcher, working memory includes 4 components: a phonological rehearsal loop, a visuospatial sketchpad, an executive control system, and an episodic buffer. And Baddeley's model of working memory has generated an enormous volume of research. So, for example, one line of research has shown that people vary in how well they can juggle information in their working memory while fending off the distractions. Working memory capacity is a stable personal trait that appears to be influenced to a considerable degree by heredity. And that said, working memory capacity can be temporarily reduced by situational factors such as pressure to perform or remuneration. And interesting, people with greater working memory capacity tend to be especially flexible and effective in their allocation of working memory. So, long-term memory. While most researchers agree that long-term memory has what we call an unlimited capacity capacity, that is, that our memory store never really gets full, much debate remains over whether storage in our long-term memory is permanent. Flashbulb memory and hypothesis-based memory suggest that long-term memory is indeed permanent, and the only reason we forget is that we're unable to access information that's still in our long-term memory, which we call interface theory. Research shows, however, that flashbulb and hypothesis-based theories are not always accurate. Is the information still there, or does it decay over time? And we make up for this by building up decayed memories so that they make sense for us. We build up memories. And so the short-term and long-term memories, are they really different? We used to think that phonemic encoding occurred in short-term memory and semantic or meaning-based encoding occurs in long-term memory. Now we know both occur for both. So we also used to think that decay occurred in short-term memory and interference occurred in long-term memory with regard to how we forget. But now it's unclear what exactly occurs in long-term memory, and it may be indeed both in long-term memory. Some researchers argue that actually short-term memory and long-term memory are the same thing, and that short-term memory is just a little part of long-term memory, and that is that it is the state of heightened activation, although multiple stores in the various areas, that's still dominant.